Out among the millions of stars in the vastness of space is our glowing sun. It is dangerous to look at the sun without very dark glasses. It could hurt the eyes or even cause blindness. But with the aid of dark glass, we can look at this round, fiery ball. Scientists have devised special instruments to observe the seething hot gases on the surface of the sun, where the temperature is over 6,000 degrees centigrade, a temperature about 4 times hotter than we can obtain from burning coal. Exploding gases leap out from the surface of the sun for hundreds of miles, giving off heat waves, that is, waves of radiant energy in all directions. Each square yard of the sun's surface sends off enough radiation to create some 70,000 horsepower of energy per day. 70,000 horsepower is enough energy to pull 12 trains, each with 50 carriages. Only a small portion of this enormous quantity of radiant energy reaches us. Even this amounts to about 1.5 horsepower per day for each square yard of the Earth's surface, just enough energy to drive a motor mower such as this. Yet this energy, small though it may seem, is virtually the source of all other forms of energy. Indeed, without energy from the sun, the world would be a frozen waste without life of any kind. To reach the Earth, the sun's energy must travel 93 million miles through nearly empty space, space as cold as anything can ever be. The following demonstration will make this clear. The air has been pumped out of this glass bulb. We can say that it is almost free of air, somewhat like the space between the sun and the Earth. Yet, as soon as the metal wire turns white hot, it sends out light in all directions and also heat. The heat travels through the empty space. The thermometer registers the rise in temperature. This is an example of radiant energy, of energy which is projected in all directions and which travels through space. The sun produces these tremendous amounts of energy by thermonuclear reactions. On the sun and on all the stars, thermonuclear reactions are occurring all the time. These reactions keep the sun and stars shining. In this process, protons in the nuclei of hydrogen, the lightest element in nature, are transformed under extreme heat into nuclei of helium. But the weight of each newly created helium nucleus is less than the sum of the particles that made it up. Some mass is obviously missing. It has been converted into energy, the radiant energy upon which all life depends. In this thermonuclear process, the sun loses about 5 million tons in weight every second. However, the sun will continue to give off radiant energy for millions of years, partly because of its size. The sun is so large that compared to it, 100 Earths would appear no larger than this dot, and 1,000,000 Earths could be placed inside the sun. The small amount of the sun's total radiant energy that reaches the Earth is the source of virtually all energy on Earth. Energy in running water, energy in food, and energy in fuel. The sun's radiant energy warms the Earth and the atmosphere that surrounds it. It warms the surface of oceans and causes the water molecules to move faster. Those at the surface break away and rise upward into the cooler regions of the atmosphere. There, the water molecules condense as drops and form clouds. Eventually, the drops fall back to Earth as rain or snow. In this way, the sun's energy sets in motion a great water cycle in nature. Millions of tons of rain and snow fall each year upon the land alone. This huge volume of moisture, raised into the sky by the sun, falls back to Earth to fill the lakes and streams and reservoirs. Thus, the water is supplied for the great dams and the tens of thousands of streams and waterfalls scattered over the Earth. So, by causing the great water cycle in nature, the sun is the source of energy in falling water, energy which turns the wheels of turbines and produces electricity for our homes and industry. The sun's rays warm the earth and its atmosphere and set air in motion, and moving air causes winds, another source of energy. The sun's rays warm the land and the air above it. Heated air becomes lighter and rises. The air outside, being cooler and heavier, flows in. This flowing air we call the wind. Moving air has energy. It makes the windmill turn and do the work of pumping water. Moving air may move boats or turn wheels. Most important, the wind carries rain clouds from the oceans to the land and provides water for the growth of plants. Plants, another important source of energy on Earth. Only plants can use the sun's energy to make food. Let us imagine that these symbols represent carbon dioxide and water. When sunlight strikes the molecules in the leaf, in the presence of chlorophyll, the green substance in plants, the sun's energy causes the molecules to rearrange themselves. In this process, plants make sugar and starches out of water and carbon dioxide. The chemical energy stored in plants is also the source of all fuel on Earth. Trees are like enormous storehouses of solar energy. When we burn wood, we release some of the solar energy that the plants have stored. Coal, gas, and oil are also products of the sun's energy. Millions of years before man appeared on Earth, forests grew tall and thick. Trees grew, died, and fell. New ones sprouted up and grew over them. All these plants, with the sun's energy stored in them, were covered over and pressed down into the earth until they turned into the dark, stone-like mineral we call coal. This piece of coal still retains the shape of a tree. Plants and many kinds of animal which lived ages ago near or in the warm seas died, piled up on the sea bottom, were covered with sand and mud, and eventually turned into the dark liquid which we call oil. We have learned to tap these underground storehouses of radiant energy and use them as fuel in our furnaces and engines. Every day we use more and more of the sun's stored energy, more aeroplanes, more cars, more factories, and more homes. All of them depending on the sun's stored energy. How long will our reserves of coal and oil last? This is an important question. It takes a very long time for plants to change into coal or oil. Today we are using up our known full resources more rapidly than they are being replaced. What then is the answer? Scientists are looking for it in the tremendous amounts of solar energy now going to waste without benefiting mankind. This man, for instance, is designing a so-called solar house, which will be heated by the sun's rays alone. Here, the sun warms the water in the boiler directly, and the warm water in turn heats the house. The sun's energy can produce electricity. When the sun's rays strike this new kind of battery, the battery gives off enough electric current to operate a walkie-talkie radio. The sun's rays even drive this tiny motor. Someday, larger ones may be constructed, using more of the sun's energy directly. This is only the beginning of a new field of science. Whether we use solar energy directly or indirectly, it is important to remember that neither man nor his machines can create energy. It must be obtained from something which already contains energy.